Hi, Buchang.
Morning, John.
How are you?
Good, I guess.
Good,
Friday.
thank you. Yeah, almost.
Yeah.
Hello, Boone, and hi, John.
Hi, Mark.
I'm
Mark, I don't know if we met before.
Yeah, maybe we didn't. I'm from SI2,
Oh, okay.
and I initially joined the OCP effort because of interest in the 3D packaging topic
Okay.
and chiplets. Uh,
hmm
and so I've participated in work groups on MDK and ADK, and now I guess this is transitioning into a work group about test. That's my understanding.
I think today is SIPI.
Oh, okay.
I think how Dave has it set up is we alternate every other week. So next week will be the test discussion, then SIPI, so on and so forth.
Oh, I
And then
see.
I think those other meetings are the following hour that also are on kind of a rotating cadence.
I get it. Okay,
Yeah.
thank you. And which organization are you from?
I'm with Siemens. So I'm a field application engineer at Siemens. So
Okay.
working in SIPI of advanced packaging, and PCBs, interconnects, everything.
Oh, okay. Well, nice to meet you.
Yeah, nice to meet you, Mark.
Hey guys.
Hi, Dave.
Hello, David.
Okay, so it came just in time for us to get started. Since Mark is here, Mark, what's the latest development on the ADK stuff at IEEE? Do you have any update?
Yeah, I do. Because there was just a meeting earlier this morning about that. You know, the work group meets every second week on Thursday morning. And today was the third meeting of that work group, and the first one in which we actually started looking at some of the technical content. So at today's meeting, the leader, Sandeep Goel, from TSMC, took us through some slides that described uh, parts of the format, mostly showing how physical connectivity is represented, but also showing some other concepts. The IEEE is working, there's some work happening with lawyers to make sure that the document itself that TSMC contributed is legal as far as IEEE documentation is concerned. And I think they need to make sure that there's nothing in there that would violate any export compliance rules or something like that. So as a result, they didn't actually show anything about the document yet, but they think they'll be able to do that by next meeting. So instead, these slides that Sandeep went through are slides that have already been seen in other forums. There's nothing proprietary or secretive about them.
So when you talk about export rules, TSMC being a Taiwanese company, which export rules are you looking at? Well, obviously US rules, but would that be looking at the Taiwanese export rules, or do you know?
I don't know the details about that. I just know that they said the document itself is being held up by some sort of legal review, and they said something about export. They said that there's nothing about the syntax itself described in the document that we won't be able to see. They may have to, but TSMC may have to remove some examples they provided in the document because the examples may have some technology descriptions that are not considered okay. That's the level of my understanding.
Okay. Yeah, yeah, okay. Yeah, that's a good clarification because I didn't see how syntax would be export controlled.
Right, okay.
Right. Okay. Yeah, that actually makes sense. That's interesting. So if the syntax is not export controlled, then somebody writes a code that to parse it, that code could be export controlled, right?
I don't know. I don't know. They're getting into the
Yeah.
realm of the law. I don't know.
Yeah, I can see how the lawyers are going to be a little bit busy with this topic.
Yeah, I think
Um,
it's just a matter of IEEE wants to make sure that if they take ownership of the document, that they don't get into trouble for anything.
yeah. Yeah, that makes sense. Okay, good. That's a good update. What is the overall timeline that IEEE is looking at to publish this as a standard?
I asked
Uh,
that question myself at one point, and I didn't get an answer yet. And what I've been told is that often these standards take like 2 years or so to go through and finally get approved. Um, I get the feeling that TSMC is hoping that this one will be faster than that. And one thing I asked for was a kind of a timeline for the activity of this work group that would show the phases we need to go through in order to review and get feedback and finally um, produce a version that is then meant to be the standard, and then I know it needs to be approved as a standard. So I asked for that timeline, but I don't think they have it yet.
okay. Okay, interesting. Yeah, it would be interesting to find that out because I remember many years ago when open document format XML was being pushed through IEEE. Microsoft came and standardized their Word, their what is it, docx file format. They did that in about 6 months.
Okay.
But that was Microsoft pulling all the strings, right? Pushing it through. So they were actually able to beat the open document format, ODF, back then. So I guess between 6 and 9 months would be the timeline.
Uh-huh. Okay,
Okay.
well, yeah, I mean, whenever more becomes known, I'll let
Yeah.
you know.
Yes, thank you for that. Yeah, we're very keen to see what comes out, how it looks, and how we compare.
Okay.
Okay, so let's switch to the main topic for discussion for this week, which is SIPI. I think, John, how are you progressing on summarizing some parameters that we need to cover?
Yeah, Dave, so I wanted to make sure I was looking in the right place. So in the CDX Workstream, there's a bunch of meeting minutes that I saw, and I think that's the document you linked me to last time. And it had basically, so let me see if I can
Yeah,
share
there's
my screen here.
there's a couple of places. One is the meeting minutes. That's the main one.
Yeah,
Um, I
okay.
had I had taken the content from the meeting minutes that SIPI related and put it in a separate document. If you worked on if you're looking at the meeting minutes, that's fine. The content in the separate document is the same. Basically, it was a simple copy paste, so it's not lost.
Got it.
The
Okay.
work.
Yeah,
Um,
so
eh, Actually, do you know how to find the other documents?
I think it's just, is it linked in the folder in the meeting?
It's in the 3DK. Yeah, it's a CDX folder, and then there is a 3DK subfolder in there.
CDX and then 3DK subfolder.
Yeah, let me first post the link to the folder, and
Oh,
then
SIPI. Okay.
right, you saw it, right?
SIPI kit. Oh, okay, there we go.
Yeah. That's again, if you look at it closely, it's just a copy paste. Section 3, I believe, is just a copy paste
Yeah,
of the meeting
okay,
minutes.
I see. Yeah, so Dave, I looked through that. I reviewed a lot of the parameters. Most of what is in there is okay. There's some things that I can clean up, just the verbiage. Um, a lot of the parameters that are discussed actually are already spec'd, kind of placeholder specs in either UCIe 1 or UCIe 2, or they're kind of, they don't have analogs for other interface types, so whether that's BOW or AIB. So
Yes.
some of the parameters are going to be a little hand wavy, right? Frequency domain metrics, for example. So I went through and I basically just tabulated everything that's available per spec. So what I can do, Dave, is just
Okay.
dump that into that placeholder document. I'll just append that in
Yeah.
there. There's a few tables. Um, I'll go ahead and pull that up real quick.
Yeah, pull it up if you want. Yeah, it's actually a working meeting, so we can do that right now if you want. What
Yeah,
I'm gonna do
absolutely.
is put the line in section 3 that kind of this is uh, I'll just say old meeting minutes in
Okay.
section 3, and you can post it above that. Oh, okay, let's take a look at it. Um,
Yeah, so basically just the spec, data rates that are defined. So as I go through, there's some other places,
can
right?
I?
Depending. Yeah, go
Okay,
ahead.
let's go to these one at a time if you don't mind.
Sure. Yeah, absolutely.
Uh, so when we are talking about data rates, are those discrete values or are those ranges?
Ranges.
Okay, so for example,
So
UCE, I can make it run at 26 gigabits, 27 gigabits, 28.
so it's spec'd out at 2, 4, 6, 8 in those intervals. So I can certainly call out each one of the ranges. I'll make a note to spread that
Yeah, but yeah,
with these
what I mean is,
individual bins.
what I mean is the actual IP expected to operate at exactly that frequency, or it could be a little bit off, right? So, for example, the 32 gig, although the IP is spec'd at
Could
32
run
gig,
it 27 or
okay, so
yeah.
so
I'm so we
it will actually auto negotiate the actual speed, is it? How
well.
does
So
that work?
what I can say, looking at like DDR systems, for example, you can run those modes in off-center data rates. It's just not necessarily guaranteed. Let's say if you've got a Micron vendor model, they will guarantee the operations at JEDEC defined data rates. If you decide to run off speed, you have to go in, adjust all of the controller timings, all of the margins, because those are all based on those speed bins per the spec. So if you want to run at a lower data rate, that's okay. You just have to go in and, whatever analysis engine you're running, those configuration parameters would have to be changed.
Okay, so then that will be the software that is running on that IP will decide how to negotiate the speeds, right? It will start at 32, and if it cannot, it will decide to drop it to modify the registers and drop it to 30, 28 until it gets connectivity. Is that the typical use case? I mean, I'm not sure if my question is clear.
I wouldn't necessarily say that's the typical use case, Dave, but I mean, certainly it's possible to run in non-spec speed bins. I think that's the
Okay.
question you're asking.
Yes, that's a good question. Okay, yeah, but I mean, from design point of view, we are designing the IP is spec'd up to X frequency X, and all the design that's ongoing is meant to hit that frequency X, and then it will be actual operation that will determine where it can hit the frequency X, or if the software is smart enough to fiddle with the registers and get it X minus 5% so that it's not dropping to half X, right? It's still finding the maximum frequency that it can operate.
Yeah, I mean, I think that can be put together.
Okay. Okay. Yeah, thank you. I think that answers my question. The reason I'm asking these questions is whether we need to right, from modeling point of view, the question is, do we give users a explicit kind of a choice of discrete values that they have to choose, or do we give them defaults and then ranges? Because, say, for example, power, if it's frequency dependent, right, it actually would matter if you're running at a little bit lower speed, right? Your power consumption is going to be lower, so maybe you want to know that, right? Or if you want to, I don't know, play power saving games or something like that.
Sure. Yeah, I see what you mean.
Yeah. Okay.
Mohammed, do you have any thoughts? Do you have any thoughts on that?
I think you already answered. From the compliance, probably, yeah, we need to make sure for the IP to be compliant with whatever, standard is asking. But I think throttling can be done per my
Yes.
software, per my understanding. Yeah.
Yep. Yeah, that shouldn't be an issue, Dave. It will just be a matter of adjusting those specific parameters, and a lot of those parameters are already called out in the working document, and so maybe I can go through and put some asterisks, some of the values that would change if you're running in those non-spec speed bins.
Yeah.
And then I can list them out explicitly, the ones that are already defined and then forward looking, what they're thinking about going to.
Yeah, this may be interesting. Actually, I don't know if all IPs are the same. in the sense that would IPs even have the control to let you run at a little bit lower frequency versus don't allow that and just run at the discrete speeds, right? At 32 gig or 16 gig. That's it, right? If you cannot do 30 gig, you have to drop to 16.
Right. Right.
Because I can see how that would be allowing different fine control to drop to different frequencies, maybe a complexity on the IP that some people may add, some people may not add, right? Or may not want. Okay. Yeah, okay. We beat on this first line too much.
Sure. Well, that's okay.
Yeah.
So I will say I've got a hard stop in 15 minutes. I've got another meeting that I've got to go drive to. So
Okay.
we can continue the discussion, as long as, but I've got a hard stop. And then, like I said, I'll go in, populate these notes into the working document and
Okay.
make edits to the existing section. But yeah, like I said, this is basically just kind of tabulated together everything that's available, for the common die-to-die specs. So looking at bit error rates, typical jitter parameters, I can get some actual values and put those in there. Interesting one is eye height, eye width for AIB, BOW. These are not spec'd. Any metrics are purely in the frequency domain. So we're looking at insertion loss, return loss, and crosstalk metrics, basically purely for the interconnect. And then we're going to assume that if we meet those criteria, it will result in a good enough open eye. We're not saying what those eyes need to look like. For UCIe, however, those are very clearly defined per speed gain. So for up to 16 gigatransfers per second, looking at 40 millivolts opening, 0.75 UIs, and then the UI drops a little bit at the higher speed bins.
Okay. So on the eye height width, you probably saw my crappy drawings in the document. We had a discussion about whether it's a diamond shaped eye or if it's rectangle shaped eye. And I think I recently saw somewhere that one of the proposals is for die-to-die interfaces to switch to diamond shape eye requirements. What are your thoughts on that?
Let me hold on. I'm gonna stop sharing for a minute if I can find my Zoom window.
I know for UCE it's a rectangle eye. Some of the series is diamond shape. I don't remember in what context I was looking at that, but
Yeah, I mean,
definitely
so
talking about them.
there are diamond shaped masks for LPDDR5.
Yes.
You know, I would say that we would just have to, we would have to run a bunch of cases. That's really the only way to determine if going to a diamond mask would be beneficial. Did they provide any justifications, or do they have cases that are failing the rectangular mask?
Yeah, there was a case where it's failing rectangular mask, but passing a little bit bigger. Right, because of the corners, right? The diamond shaped mask is actually a little bit bigger. It will fail rectangular, but it will pass the diamond shaped mask, and they were saying that's okay, right? We can work with that. I have to go back and see what context I was looking into that. But yeah, I guess my question is, probably here, specifically when specifying the mask parameters, we should consider giving an option whether that's a diamond or a rectangular shape eye mask.
Yes, agreed.
Because I've seen people run die to die, and then accidentally apply a diamond shape and say, "Oh, this is passing." Looking at the height and width, and no, it's not. It doesn't fit
Right. I
the
mean, you
rectangle.
could just change. You can change the mask, right, and then you go from a pass to a fail. So
Exactly. Yeah.
certainly an interesting discussion, and yeah, that requires just a lot of simulation, simulating a lot of corners, a lot of variance, a lot of speeds. Um, I'm not involved in those discussions, so I'm probably not the best person to ask on that one.
Okay, so hang on a second. You're saying that the determining the eye mask for rectangular shape versus diamond shape simulation wise, it's different.
Well, no, what I mean is if you were making the determination if you were going to change, so right now I believe UCIe calls for a rectangular mask. I was looking for what those parameters are. I have it in some presentation.
Yeah.
But I'm just saying the amount of simulations that you would have to run to confidently say, okay, what's abandon the rectangular mask to, we're getting
Oh yeah.
consistently. I don't know who's running that analysis. I'd obviously be more
Okay.
than willing to run some cases on our end.
Yeah. No, I was thinking from a different point of view that the standard itself determines with whether it's a rectangular mask or diamond shaped mask. Right,
Correct. Yes.
right. Not necessarily that the user will go and switch that on their own and determine whether they can use something else. I meant from creating a model, and if the standard says this is the size of the eye mask, probably it's a good idea to say this is a rectangular eye mask or diamond shaped eye mask.
Yes. I mean, the
Right.
implementation of the mask in whatever software they're using to run the simulations needs to match the spec, right? So if it's
Yes. Yeah.
rectangular,
Yeah.
configure the rectangular mask. If it's diamond, we'll configure the diamond mask.
Yeah. Okay.
Yeah, I mean, to answer your question, absolutely. Whatever the spec is, that's what it won't be on this won't be on the user to determine, hey, I can just switch the mask and all of a sudden my interconnect is passing. No.
Okay. So we have, I guess you have a couple more minutes. Do you want to flash your slides quickly? I'll stop asking
Yeah.
questions, just see what's in
Oh,
them.
no, it's totally fine. The discussion is good. Yeah, let me go ahead and share again. Okay, clocking source synchronous, different clocking schemes per interface. This is probably the most interesting. So regarding frequency domain metrics for channel loss, return loss, insertion loss, basically looking at the Nyquist, these are pretty, I would say they're not necessarily too aggressive targets. They're not necessarily anything different that we're seeing in like high-speed SerDes. And the fact that, our channel links are relatively short, except for maybe some of like UCIe advanced cases. I don't anticipate, these metrics changing at all, really.
Okay. Yep. Okay.
So all of these things, and on our end, I'm working with the Siemens teams to get these masks kind of pre-populated in all of our different wizards and forms, S parameter
Yeah.
post-processing, so that we'll just be able to, you have the S parameters. If you know it's UCIe running 16, here's the frequency domain mask that you need to meet.
Mm-hmm. Yes. Okay.
The PDN impedance, this is really more of a guideline. I don't think this is explicitly called out in the spec. This will be highly dependent on the max current and noise tolerances per die. But in general, this is kind of what we're seeing. Target less than 5 milliohms for UCIe type of channels. Which is fairly aggressively low for a
Yep.
PDN,
Yep.
but it can be achieved with some difficulty.
So this
Um,
this one, for example, would be I guess there's two sides to look into this. One is uh, recommended by the standard, kind of like a guideline, right? And then the other one would be the actual IP vendor giving you the IP and telling you, I want exactly this much, right? Not more than that.
exactly. Yes.
Okay.
Equalization techniques required for UCIe, not specified for AIB or BOW. So this will be
Yeah.
just on individual, IP implementation.
And you see they're required for the 24 and 32 gig, right? Not for 16 or
Correct.
even 16.
I'll confirm that, Dave, but they're absolutely required for the highest speed grades,
Yes.
and I'll make a note on which speed grades those are
Yeah.
required for or not required.
Mm-hmm. Okay.
And then just some follow-up information, nominal supply voltages, again, target impedance, some supply noise. These are very hand wavy. Obviously, we're seeing some chiplets with very, very extremely high current demands. IR drop budget, again, that's going to be highly dependent on the particular interface and particular PHY that we're looking at.
Yeah.
But yeah, so I'll go through, Dave. I'll get this cleaned up a little bit, and I'll just append this into that document. And then we can
Yeah.
go
Feel
from
free
there.
to. Yeah. Whenever you're ready, even if you want to dump it now and edit it later, that's fine.
Sure.
I think it was beneficial for everybody to do one scan of these. And so next time we are prepared with a little bit more questions. Like,
Yeah.
for
No, that
example,
sounds good.
what's CDR for clocking?
But I don't have the acronym in front of me. Sorry.
Okay. Okay. No,
Clock
that's
and
okay.
data
All right.
recovery.
Yes.
Clock and
Yes.
data.
Sorry. Say that again.
Clock and data recovery.
Clock
Oh,
data
okay. Oh,
recovery.
yeah.
Yes.
Okay. Okay.
Yeah. Thanks, Mohammed.
Yeah.
Sure.
And this CDR would typically applies to SerDes type interfaces, right? Would that apply to parallel interfaces as well?
Yes.
Or
Yes, I think it depends if the clock is being, forward clock is there or not, or it is part of, recovery CDR circuit on the receiver side.
okay, yeah, we should. I guess we can discuss this a little bit next time. I want to understand what we need to put in the model that would allow for matching interfaces, right? Right. One of the reasons for using this is apart from setting up SA simulation, even for basic interface choosing, right? When you have two chiplets at the very basic level, you want to know that on both ends it's matched in terms of functionality, right? And
Yeah.
if one IP expects one and the other one expects something else, obviously these cannot be matched. It will not work.
Right. Not
Right.
interoperable. Nope.
Exactly. So I wanted to understand that. Would want to understand that a little bit next time.
Okay. Yeah, I think definitely some things we can circle back on and talk about.
Yeah. Okay. Yeah. This is great, John. Thank you very much for this. Yeah. As I said, if you could dump it in that SAPI kit document.
Will do. Yep. I'll put it in
And-
there later this afternoon.
okay. Yeah, and we can browse through it and see if anything else we need to worry about.
All right. That sounds good.
Or
Well,
if you have a
thanks.
question.
Yeah. Sorry for having to drop early, but appreciate the time, and I'll talk to you guys soon.
Okay. Thanks, John. Thanks a lot.
Yep.
Thank
Thanks,
you,
Dave.
John.
Thanks, everyone.
Thanks,
Bye.
everyone.
Okay, so for everybody else, I think it would be a good idea to take a look at the document once John does the update, see what parameters are there, see what you think about matching different IPs. If anything might be missing. I don't think so. John is pretty thorough, but anyway, right? If we need to do different kind of modeling for some of the parameters, right? As I said, there's a little bit of dependency in different cases, right? Like, does it allow different frequencies? Are they matched and so on? So please do take a look at the document once John updates it, and next time we can go to these parameters one more time and see if we can start creating first cut models that will capture this date.
Okay.
Okay. I think we can conclude for today unless somebody has any thoughts.
Well, okay, you said please look at this. The URL you posted in the chat, is that the URL to what John was just showing?
Not yet. So Mark, let me walk you through what that URL is. Let me find the right window. So it will take you to the CDX folder. Let me make this a little small like this. This where we keep all the working documents and working copies, stuff like that. This should be world readable. If you go to 3DK, you're gonna see the different pieces of 3DK, and if you go to SIPI, here is the document that John is going to update. Now, don't be scared. This is a template. This started off with a template, but section 3 here is the one that we are looking into, that captures old meeting minutes, stuff like that. And John is going to update this section and dump the tables so that you can.
Okay.
Yeah, let's see this. Okay, this is a new feature that Google has. What is this? Control. Oh no, Option W. Option W is summarize the text in the section below. Summarize. Let's see. Oh, cool. All right. Okay. AI to the rescue. All right. Anyway, okay. Muhammad Boon, any last thoughts?
No, that's good. I will also
No.
take a look, and maybe next time we can deep dive further into these specs, and how we want to put it here in the eventual document. Yeah.
Okay, sounds good. All right, Boon.
No, not for me.
Okay, awesome. So Boon, go. You're free to go back to sleep, and we'll talk again
Yeah.
in 2 weeks.
Okay. Bye bye.
All right, bye.
Thank you. Bye.
Bye.